Fazil, Noor, Sania, am I audible?
Yes, sir.
So, Sania, you were absent yesterday.
Sir, I forgot. I was sitting at 12:30 p.m. I was logging.
So yesterday we have completed differentiation. So you can check this YouTube channel, Learnivio.
Okay, sir. Okay.
For this
Thank you.
one playlist by the name of UA.
Okay.
In that playlist, that is the lecture on differentiation. So we completed differentiation yesterday. The next is integration.
Okay, sir.
So here integration is just the reverse process of differentiation. Just like multiplication and division. If we have done division and want to go few steps backward, then the inverse operation of division is multiplication. Just like if you have differentiated something, then the inverse process of differentiation is integration. You can say it's inverse of differentiation. This is inverse of differentiation. Let's check the physical meaning of integration. What is physical meaning? So let's consider a rod. The total length of the rod is L. The total length of the rod is capital L. Charge distributed over the rod is Q. Q is the charge distributed over the rod. If I consider a small element dx of the rod, dx means infinitesimal small element, very minute elements. Infinitesimal small element is known as dx. Dx extremely small. You can say that dx is like 0.00001 meter or even smaller. Dx is infinitesimal small element. So, Sania, can you just count the number of dx from A to B? The number of dx element from A to B. It would be finite or infinite?
So what you said?
I'm asking the number of dx elements from A to B. How many elements dx are there from A to B? This is one dx element. I can consider another dx element, one more dx element. So how many dx elements I can take from A to B over the entire rod? Will it be finite or infinite?
Infinite.
Infinite, because the dx is extremely small element. So from A to B, you have infinite dx. What if combine all dx from A to B? Dx is small length. Like you have a rod, you divide this rod into very small elements. Each of that individual small element is dx. What if I combine all these small elements from A to B? If I combine all dx, if I'm combining all dx elements from A to B, what it would be? So if I combine all elements, then this the total length of the rod.
Yeah, total.
You have divided the total length of the rod in very small elements. So if I combine all small elements from A to B, then that will be equal to the total length of the rod. This is the physical meaning of integration. So physically, integrate means you are combining elements from one point to another, because A as lower limit and this B as upper limit. Some applications of integration. We will see how to integrate an expression, formula of integration and everything. But before formula of integration, let's check the application of integration. Where you will use integration in physics. The application of integration in physics. Like if you have displacement and time, if you divide displacement and time, you will get velocity. But to get displacement, you need to multiply velocity and time, right? Displacement is velocity into time. So the first application of integration is displacement is S is integral of velocity from some initial time to final time. Displacement is integration of velocity. The way displacement is velocity into time, displacement can be written as integral of velocity from some lower limit to upper limit. We use this formula if your velocity is constant. You'll be using this relation only if your velocity is constant. But if your velocity is variable, then you can't just simply multiply them. If your velocity is variable, then you have to use this expression. That's the first application of displacement. We will do this thing in much detail when we start motion in 1D. But for the application of integration, that's the first application, that displacement is integral of velocity with time. The second application is change in velocity. Change in velocity. Change in velocity is integral of acceleration with respect to time. We're integrating acceleration from T1 to T2. This is acceleration. Yesterday we did just the reverse thing. If you have you need velocity, then that is differentiation of position or derivative of displacement. Acceleration was derivative of velocity. Yesterday you were given displacement, you were supposed to calculate velocity. Velocity was given and you were supposed to calculate acceleration. But now velocity is given and you are supposed to calculate displacement, inverse calculation. Acceleration is given and you're supposed to calculate change in velocity, inverse operations. So these are two applications. One is displacement and the second is change in velocity. The next is some formula. For different types of function, these are two applications of integration that we will use in kinematics in your chapter number 3 as well as in chapter number 4. Next, the formula of integration basically depends upon the type of function. Just note it down, I will erase it and then we'll start with the formula.
Okay.
You will use integration more frequently than multiplication in chapter number 3 and 4. Okay.
Done, sir.
Fazil, shall I rub it?
Yes, sir.
Next, the formula of integration depends upon the type of function. Say you have a polynomial function. You have a polynomial function. Polynomial function means a function of the form x to the power n. x1 to x2, x to the power n dx. This is polynomial function. So the integral, the formula of integral is, this x1 is the lower limit, this is the lower limit, and this is the upper limit. The formula of integration is, this is x to the power n plus 1 divided by n plus 1. The limit is from x1 to x2. That's formula of integration. If you're integrating x to the power n dx, then this is x to the power n plus 1 over n plus 1. Then take this n plus 1 outside the integral. So this is x to the power n plus 1 from x1 to x2. The next step is to substitute limits. It's 1 by n plus 1. Just start substituting limits. Like instead of x, just substitute x2 to the power n plus 1. Minus. Instead of x, substitute x1. So it's x1 to the power n plus 1. So that's limit substitution. So it's 1 by n plus 1 x2 to the power n plus 1 minus x1 to the power n plus 1, it's 1 by n plus 1. For example, say you are integrating x square dx from 1 to x square dx from 1 to 2. So this is x to the power, say instead of n you are using 2, it's n plus 1, so that's 2 plus 1. Divided by n plus 1, it's 2 plus 1. And the limit is from 1 to 2. So this is x cubed by 3 and the limit is from 1 to 2. This is 1 by 3 x cubed, limit is from 1 to 2. This is 1 by 3, it's x cubed, that means 2 cubed minus 1 cubed. Upper limit is 2, lower limit is 1, so it's 2 cubed minus 1 cubed. So it's 1 by 3, 8 minus 1. So this is 7 by 3. So this is the integral, 7 by 3. Is it clear, this example?
Yes, sir.
Yes, sir.
And these relations are absolutely independent of variable. Like instead of x, if I am using t, if I write this as it's 1 by t square dt, limit is from minus 1 to plus 1. The formula is same. You just have to convert this 1 by t square in the standard form. The standard form is x to the power n, not 1 by x to the power n. So just make this 1 by t square as it's minus 1 to plus 1, t to the power minus 2. This is the standard. Okay, now integrate it and get the panel. Now integrate this expression and get the panel. Okay, Sania got 1. Noor, answer of Noor is -2. And what about you, Fazil? 0. I think Noor is correct. See, this is t to the power -2. So this is, it's -2 plus 1 divided by -2 plus 1. And the limit is from -1 to plus 1. So this is simply t to the power -1 by -1. And the limit is from -2 to plus 1. So you can write this as 1 by -1. T to the power -1. You can write this t to the power -1 as 1 by t, and the limit is -1 to plus 1. So that's 1 by -1 is just -1. It's 1 by 1 minus 1 by -1. Right? Instead of t, substitute the upper limit, that's 1. Then lower limit, which is -1. So it's minus of, it's 1, minus minus is plus, it's plus 1. So it's -2. So when you integrate it from -1 to plus 1, it's -2. This is the integral of 1 by t square dt, that's -2. So Noor is correct. Fazil, you are missing this negative sign, I think. Is it clear? Okay, so shall I erase it?
Yes, sir.
Solve one more question. Velocity of a body is v equal to t to the power half meter per second. So it's a variable velocity, it varies with time. Calculate displacement covered in 0 to 2 seconds. So displacement is simply the integral of velocity from initial time to final time. So velocity is just t to the power half dt. Okay, 0 to 2. Instead of 2, yes, keep it 2. So it's t to the power half dt integral. Just solve this whole expression and write and report your final result. Answers Okay, Fazil got 2, Noor 2 by 3, 2 to the power 3 by 2. And what about you, Sania? Your answer? 2 by 3. Okay. So let's start the calculation. So this is basically 0 to 2, t to the power half. So the integral of t to the power half is t to the power half plus 1 divided by half plus 1, and the limit is from 0 to 2. So the displacement is it's t to the power 3 by 2 divided by 3 by 2, and the limit is 0 to 2. So displacement is 2 by 3, it's t to the power 3 by 2, limit is from 0 to 2. So it's 2 by 3, it's 2 to the power 3 by 2 minus 0 to the power 3 by 2. So this is 2 by 3, 2 to the power 3 by 2. You can write this 2 to the power 3 by 2 as 2 to the power half and then cube. And this is almost 0. Sania, you're making mistake in this calculation. Fazil, again, you two are making mistake in the same calculation. 2 to the power half cube minus 0. So you can write your displacement as it's 2 by 3, it's 2 to the power half cube. So that's root 2 into root 2 into. So root 2 into root 2 into root 2 is 2 root 2. So the displacement is 2 by 3 multiplied by 2. So the displacement is it's 4 root 2 over 3. So this is the total displacement, which is 4 root 2 divided by 3. This is how we calculate total displacement. Noor is correct. Noor, you just haven't complete the calculations. Otherwise, Noor is correct, but Fazil and Sania were making some mistakes. Is it clear now, Fazil, Sania?
Yes.
Sir.
Okay. Note it down. Let me do some more properties of integration. Shall I raise it? Sania? Fazil? Sania, Fazil, shall I raise it? Sania? The next property is if you have a constant integration, if you have a constant function, just one more. After polynomial function, the next is trigonometric function. Check some formula for trigonometric function. If you're integrating sine x from x1 to x2, if you're integrating sine x from x1 to x2, then the integral of sine x is minus of cos x. Limit is from x1 to x2. So it's minus of its cos x2 minus cos x1. This is the integration of sine. You can even integrate x1 to x2 cos x dx. So the integral of cos x is sin x. Limit is from x1 to x2. If I substitute limits, then this is sin x2 minus sin x2. Then integration of other trigonometric functions as well, like for tan, cot, sec, cosec. But we will use only sin x as cos x. So I'm not discussing other trigonometric functions. That's more than enough for you. For your NCRT and for numericals of physics, you will use only sin x and cos x. After trigonometric functions, we will use some exponential functions. So you have an exponential function of the form e to the power x. Function of the form e to the power x dx. You are integrating it from x1 to x2. So the integral of e to the power x is simply e to the power x, and the limit is from x1 to x2. Now, if I substitute limit, this is e to the power x2 minus e to the power x1. This exponential functions doesn't change in integration and differentiation. It will remain same during differentiation and integration. The third important integral is the integral of 1 by x. If you're integrating 1 by x, then the integral of 1 by x is log x. The limit is from x1 to x2. Log x2 minus log x2. So it's log x, some upper limit to lower limit. So that's simply log x2 minus log x. Okay, just note it down. Okay. Next, we have some properties of integration. Some properties of integration. So you should remember all these 3 or 4 formulas like polynomial function, trigonometric, exponential, and the integral of 1 by x. Then we have few properties. Like the first property is few properties of integration. The first property is if you're integrating only dx, there is no other variable than dx, it's only dx. The integral of this dx is simply x. If you have just dx, no other function, there is no x to the power n, x square, x cube, just dx. Then the integral of dx is x, limit is from x1 to x2. When you substitute limit, it could be x2 minus x2. Let's prove it that the integral of the integration of dx is x. But in numericals, I will use this integration directly. Wherever you have just dx, you put it dx is equal to x1. The proofs is, say you have x1 to x2, dx1. Can I write this dx as x1 to x2, 1 into dx? This is dx only. You can write this as it's x1 to x2, 1 dx. Next, you can write 1 as this is x1 to x2, x to the power 0 dx. It's x1 to x2, x to the power 0 dx. Then you can further write this as this is x to the power 0. You can write your x to the power 0 as x to the power 0 plus 1 divided by 0 plus 1, and the limit is from x1 to x2. So at the end result is same, x from x1 to x2. See. But no need to follow all these steps in numericals. You can directly use if you have dx and integral of dx is x1. Similarly, if you have dt from t1 to t2, Sania, what should be the integral of dt? If you have just dt. Yes, Sania.
So what you asked?
Integral of dt. What is integral of dt?
X2 minus x1. T2 minus t1.
T. Limit is from t1 to t2.
To t2.
This as t2.
T2 minus t.
Simply t. Sure. After dt, the next is second property. If you have a constant time function, multiple of a constant at a function. If you have multiple of constant time function. Say you are integrating its k x to the power n dx. The limit is from, say, not k n dx. So you're integrating k some function f dx, and the limit is from x1 to x2. If you have this type of integral, then just take k outside the integral. Always take constant outside the integral. Now solve the entire integral and multiply result with k. For example, say I ask you to solve 0 to 2
Okay.
x or 3x square dx. So 3 is a constant. In the first step, take this 3 outside this integral and you are left with 0 to 2 x square dx. Fazil, what is integral of x square?
6.
Integral of x square, Fazil. What is integral of x square?
7/3.
What? No, just integral of x square. Don't substitute limit.
Oh, okay. X square plus 1 divided by 2 plus 1. Oh, x2.
Limit is,
x1. 0 to 2.
it would be
X cube
over 3.
over 3 and then 0 to 2.
This 3 will cancel this 3.
Yes.
Yes.
And you are left with only its x
2 cube.
Next, you can write this as 2 cube minus 0 cube equal to. So this is how we calculate this integral. It's 3a. This is the integral of 3x squared. Is it clear?
Yes,
Yes, it's
sir.
clear.
Just note it down. Okay. Let's erase it and then move on to next property. The third property is if you have some and
Sir,
yes,
can you show the page again? 1 minute. Yeah, done, sir.
next property. Third one. If you have addition and subtraction of functions, if you have a number of functions which are either in addition or in subtraction. For example, if you have integral of fx plus gx minus hx dx, the limit is from x1 to x2. Dx is written here, it doesn't mean it's with hx only. This dx with each of the given function. This dx is with fx as well as gx as well as hx. You can just divide this into 3 integrals. So this is x1 to x2, it's fx dx plus it's x1 to x2, it's gx dx minus x1 to x2, It's hx dx. Solve each integral separately and then simply combine. For example, so I'm integrating 0 to 2. Let's start with velocity. So velocity is 3t square plus 2t plus 1. Calculate displacement. Calculate displacement in 0 to 1 second. So displacement is simply integral of velocities. From 0 to t, you have to integrate v. So this is 0 to 1, it's v. v is 3t square plus 2t plus 1t. So the displacement is 3 terms. It's 0 to 1, it's 3t square dt plus it's 0 to 1, it's 2t dt plus it's 0 to 1. So 3t square dt, 2t dt, and then this dt. Just complete the whole integral and report your answer in chat. Complete this integral. Okay. Fazil. Okay, your answer is 2. Noor, Sania. Okay. And Sania, your answer? 2. Okay. See, this 3 is constant. We can take this 3 outside integral. It's 0 to 1 t square dt. Then again 2 is constant. We can take this outside. It's 0 to 1 t dt. And it's simply 0 to 1 dt. So the displacement is 3. This is t square. It's t to the power 2 plus 1 over 2 plus 1. Limit is 0 to 1. Then it's 2 t to the power 1 plus 1 over 1 plus 1, and limit is from 0 to 1. And this is just dt. The integral of dt is t. Limit is from 0 to 1. Yeah, Fazil, now you are correct. Sania, you are missing something. You're missing one term. So the displacement is 3. It's t cube over 3. Limit is from 0 to 1. It's 2. It's t square over 2. Limit is from 0 to 1. And this is t. Limit is from 0 to 1. This 3 will cancel this cube. This 2 will cancel this square. So the displacement is, it's 1 cube minus 0 cube. 1 square minus 0 square plus 1 minus. So displacement is 0. Is it clear now? Sania? Which term you were missing, Sania? You're missing something. Which term you were missing? Sania, you're missing a term, right? Why you were getting 2? You're missing this last term. Okay, please note it down. Let's rub it and let's start the next question. The next question is, acceleration is, so this is 3 by t square plus 2 minus 2t. Calculate change in velocity from t equal to minus 1 second to t equal to plus 1 second. So you have to calculate the change in velocity from t equal to minus 1 seconds to t equal to plus 1. Solve this integral, get the final result. So the formula of change in velocity is this. Change in velocity is simply integral of acceleration from, sorry. Time cannot be negative. Time cannot be negative. Solve it from t equal to 1 to t equal to 2 seconds. So we're integrating it 1 from 2. Okay. Answer of Noor is -3. What about you, Sani and Fazil? One by two. Noor, I think you're making some mistakes now. Noor, just check your calculation once. It's from 1 to 2. Okay, Fazil, I'm just checking your calculation. Next, Sania. Sania. Okay. So delta V is simply, it's 1 to 2. It's 3 by t square plus 2 minus 2t. You can break this into 3 integrals. 1 to 2. It's 3 by t square dt. 2 to 2. It's 2 dt. Minus it's 1 to 2. It's 2 dt. You can break this into 3 integrals. So the final change in velocity is, it's 1 to 2, 3. It's 1 by t square. It could be written as t to the power minus 2 dt. It's 1 to 2, which is 2 dt. Minus 1 to 2, it's 2 dt. Sania, your final answer. You can take this 3 outside, it's a constant. It's 1 to 2, 3 t square. Yes. It is 3 by t square. See?
Sir, but I took 3t square.
So your answer would be total.
Yeah.
Then you can take this 2 outside, it's 1 to 2 dt. Minus 2 outside, it's 1 to 2 td. The next is delta V is, you can take 3 outside. This is t to the power minus 2. So this could be written as minus 2 plus 1 by minus 2 plus 1, and the limit is from 1 to 2. Plus 2 outside, integral of dt is t, limit is from 1 to 2. Minus 2 outside, integral of this is t square by 2, limit is from 1. So delta V is, it's minus 3 by 1, minus 2 plus 1 is minus 1, t to the power minus 1, plus 2, limit is from 1 to 2. So this 2 will cancel this 2, got a negative sign, minus 1, it's t square, it's 1 to 2. So delta V is minus 3. You can write this t to the power minus 1 as 1 by t, limit is from 1 to 2. Then this is 2, limit is from 1 to 2. Then this is minus 1. T square, limit is from 1 to 2. So this is delta V, which is minus 3. Instead of t, you can substitute upper limit. So it would be 1 by 2 minus 1 by 1 plus 2. It's 2 minus 1. Minus 1, it's 2 square minus 1. So delta V is minus 3, it's minus half. Plus 2, it's 2 minus 1 is 1. It's minus 1, 4 minus 1 is 3. So the delta V is 3 by 2 plus 2 minus 3. So that's 3 by 2 minus 1. It comes out to be 1 by 2. Fazil was correct. No, it's not minus 3, it's 1 by 2. Sania, all steps clear?
Yeah, sir.
Okay, just note it down. Okay. Sania, Fazil, shall I raise it?
Yes, sir.
Fazil. Okay, so that was about integration. So differentiation and integration are over. So now we can start motion straight. Motion in straight line. Let's start motion in straight line from the concept of rest in motion. We will use integration and differentiation in velocity as well as acceleration. The next is the definition of rest in motion. Okay, time is almost over. So let's start it tomorrow. Let's stop here. We'll start it tomorrow. It's just a 1 hour lecture. In weekdays, we will have only 1 hour lecture. On weekends, it's a 2 hour lecture.
Okay, sir.
On weekends, we were doing dimensions. The next topic about after dimension should be error. I have dimension there and I've started motion in straight line. So in weekdays, we will do motion in straight line. And on weekends, we will complete that error analysis. So on that Saturday, we will complete error. But up to Friday, we will start this motion in straight line. So let's stop here. Let's continue tomorrow. Can we have class tomorrow? Tomorrow is Wednesday. Can we have it at 9 a.m.?
Okay, sir. Nice.
9 as per your time. Sania, Fazil.
Yeah.
Sir, if you have school, then
If you have school or school timing is from 9 to something, no?
8 to 11.
8 to 11.
Yeah.
Okay, so let's keep it at 11 then. If you have school at 9 or 11, yes, 11 would be fine. Can we
Okay,
keep
sir.
it at 11? But do you have school tomorrow? Tomorrow is
No, they
Second.
didn't inform us. Like,
they.
they
Well,
did not.
I know your school will start formally from this week, I guess.
Maybe, sir, from 6.
From 6 no.
Maybe.
In that case, let's keep class at 9 a.m.
Okay.
If you have school tomorrow, then I will update the timings. If you have any if you got any notification from the school, just update it on the group.
Okay.
And I will change it from instead of 9, we will have it from 11 or 11:15.